Okay, everyone, so now I asked you to try to explain what this means. So it looks sort of similar to something we looked at in the previous one, where it was 10 times $6 plus 10 times $3 plus 10 times $2.75. Except it doesn't exactly look like that anymore. It looks like this now. And if we were in class together, I would love to hear individual opinions as to what you said. So with your permission, I'm going to share with you something that someone has told me in the past that I think drives the point home pretty well. Okay, so the first thing that these folks say is, well, I'm going to look first at that $6 plus $3 plus $2.75. And I'm going to view those parentheses as it's forcing me to look at just what's inside the parentheses. Almost like the parentheses are kind of like a flag that says, do this first. And then they say, do that 10 times. And then they say, cool, now you can subtotal everything. Now you can do 6 plus 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 6 to get 60. And then you can do 3 plus 3 plus 3 plus, to get 30. And then you can do 275 to get 2750. And then I'll ask them, I'm like, okay, that's awesome. Isn't that what we did last time? And they say, well, yeah. And I ask them, why would you write all that out? And at this point, somebody in the back of the class will say, Sean, oh my goodness. Wait a minute. 6 plus 3 is 9. Plus 275 is 1175. So when I got here, I would have just said, this chunk is $11.75. And then I said, oh, that's good. And then you can write that 10 times. And as I'm saying, and then you can write that 10 times, the student goes, Sean, what did you just say about multiplication? We invented multiplication so that we don't have to add. So once you know this is 1175, then just do 10 times 1175, which is where you get your $117.50, which hopefully sounds quite familiar from the previous one we did earlier. Now, explaining why those two are the same might be tricky. Some of you may have learned something called the distributive property in your mathematics classes previously. If you didn't, don't worry about it. We'll come back to it if we need to from time to time. That does explain what's going on here. But really, what I want to focus on instead of the distributive property, so if you have a hard time explaining that number 10, that's okay. These are just notes documents. This is for your edification. Just let number 10 be. I want to refocus on what we did instead. Because there's a new order now. If you think about it, it seems like we broke order of operations, if you think about it. Because we did the addition first, and then the multiplication. But that's okay because we inserted a new symbol to force the additions to happen first. If these symbols weren't here, if those parentheses were not there, that would be a totally different math problem. That problem says we are buying 10 Candyman flies, 1 golden stone, and 1 copper John. If we put the parentheses here, that means we're buying 10 each of the Candyman and the golden stone. And by putting the parentheses here, we're buying 10 each of the 3. So the parentheses tell us, do this first. And that's the new order, the revised order of operations on the beginning of the next page. Multiplications and additions aren't going to change in their hierarchy. But if you see parentheses, and we'll eventually get to talk about all grouping symbols, mixed in, do the parentheses first. Parentheses are powerful. You've already seen them a little bit with our work with Google Sheets, but parentheses are super powerful mathematically. They bring our focus to focus on certain parts of expressions when they need to be focused on before something else. So something like this, we have to sum this up first, then multiply by 10. Now, you can do it other ways. There's nothing wrong with doing it the way I had it written out on the board earlier, which is insane. There's nothing wrong with doing it that way. But doing it that way is the same as doing 10 times, sorry about that. Let's get the eraser. 10 times the $6 plus 10 times the $3 plus 10 times the $275. And for those of you that have seen the distributive property, that's literally what it does. It turns this into this. But there's no reason to do that. If you've got the parentheses, just do what's in the parentheses first, and then once the parentheses are gone, take it from there. And that's what this next little bit on the new revised order of operations. I didn't change the old, I just added one more level to it. Cool, let's do some more. All right, here's just a few. I just threw them in. I actually was going through some of the Math 105 stuff I've done over the past and just grabbed some examples out of that. So I figured, why not? I mean, Math 105 is life math as well, so let's look at some applications of that. Here's one that shows up. Actually, these next three show up. You'll see them later when we look at LED versus incandescent versus CFL light bulbs. So here we've got $5 plus 100 times $0.001, or 1/10 of 1 cent if you're being precise. Okay. Don't worry about what this means just yet. You'll see it in Math 105. And again, just like we did before, you can type this into a Google calculator, press enter, and it'll spit the answer out. But from an order of operations standpoint, again, I see an addition and I see a multiplication. I see no parentheses. Not in this one anyway. So what happens first? Well, there's no parentheses, so you skip that step. What's next? Multiplications. So the next thing we're going to do is we're going to multiply the 100 times the $0.001, or the 1/10 of 1 cent. And when you do that, you're going to end up with 10 cents. So you have $5 plus 10 cents. Put a 0 there if it helps. And what's $5 plus 10 cents? That's $5.10. $5.10. Pretty straightforward. Now that you've seen that one, I bet you can do 12 and 13 pretty quickly. 12, here's 11. 12, $3, yep, plus 100 times 0.0014 cents. So, excuse me, 14 ten-thousandths of a dollar, which ignore that. It's don't even try to say it. I'm gonna have a hard time saying it. But it's the same math. It's the same exact problem, right? Same exact problem. Multiplication has to happen first. So we're gonna leave the $3 over here because he's gonna be added on last. 100 times 0.0014 is gonna leave us with 14 cents. So 3 plus 14 gives us $3.14. Okay, let's look at 13, which is going to be very, very similar to 11 and 12. Same math. First, 100 times the $0.006, so it's half a dollar or 50 cents, plus 60 cents. And then 50 cents plus 60 cents gives us $1.10. And that's 13. Okay, so this one's different than the previous 3 light bulb questions. But again, it's really not, is it? Because it has multiplications and it has additions. No big deal. So what's going to happen first? Well, the multiplications. But now, what if you have a bunch of multiplications like this? Well, you just go left to write and do the multiplications as you encounter them in order. So this is going to be 10 times 10, which is 100, times 9, which is 900, times 10, which is 9,000. So this whole bit right here is 9,000. Then you have this. Then you have 10 times 9 times 10 times 10. So that's 10 times 9 is 90, times 10 is 900, times that's another 9,000. Plus 9 times 10 is 90, 900, 9,000. So you've got 9,000 plus 9,000 plus 9,000, which ends up giving you 27,000. There you go. This is what shows up when you're looking at pins on your cell phone or on the keypad to get into classrooms, or your pin on your debit card, for example. It's just one way of looking at the math of password protecting things. Okay, so here's one that mixes in parentheses, multiplication, and addition. And we're going to have more of these as we go. So again, parentheses are that kind of like, boop, boop, do this first. So then you look inside the parentheses and you say, okay, but inside the parentheses, you have multiplication and you have addition. So you're going to have to knock the multiplications down first, and then do the addition. So you do 10 times, 9 times 10 is 90, plus 3 times 7 is 21. Now we're not done with the parentheses yet because we haven't added these two things together. We're going to do it now though. So you have 10 times 111, which ends up giving us 1,110. And I can't implore upon you, I can't impress upon you enough that when it comes to an expression like this, you can use your calculator to do it. You can use Google to do these every single time. What I think is kind of cool about using Google to do these is you can actually see how the computer program uses extra parentheses to kind of guide the order of operations. See the 9 times 10 and the 3 times 7? Google puts those inside the innermost parentheses. That way they happen first. Those parentheses weren't in the original problem. Google had to add them. Pretty cool, actually. Okay, now this one, believe it or not, you've already done before, but you don't realize it yet. 3 times 9 times 10 cubed. What does that mean? 10 cubed. You might not recognize that one. That's okay. Here's one you might recognize. 10 squared. I think squared gets used more than cubed in our world. So 10 squared just means 10 times 10. Just like 10 to the first just means 10. 10 cubed means 10 times 10 times 10. It's just a shortcut way of saying it, really. So another way of writing this would be 3 times 9 times 10 times 10 times 10. And now it's all multiplication, which is good. So left to right, 3 times 9 is 27, times 10 is 270, times 10 is 2,700, times 10 is 27,000. Oh, I said it but didn't write it. 27,000. That should sound familiar to you. That was the same answer we got a couple questions back. So what was up with that exponent? What's up with that exponent up there? Well, let's think about this. 10 cubed is 10 times 10 times 10. Isn't that 1,000? Yeah. So could we have done this first and rewritten 10 cubed as 1,000? Absolutely. Because then it's 3 times 9 is 27, times 1,000 is 27,000. The reason I bring this up is not to be cute or annoying, or both, probably mostly annoying. The reason I bring it up is because exponents wedge in between. And we'll see this more with later examples. Later examples, I think, are more telling. But in the next page, the order of operations revised revision, it's a little bit ridiculous with the constant revisions. You see where exponents live. They live after parentheses, but before multiplication. Because if you think about it, they are multiplication, but they're a more concise version of multiplication. When you see 10 cubed, it means 10 times 10 times 10. Just like multiplication is a more concise version of addition. That's why multiplication sits on top of addition. Well, exponents are a more concise expression of multiplication, so they sit on top of multiplication. Parentheses are their own thing. They are their own monster. They sit up there all by themselves. Okay so far? All right, let's do some more.